award at international conferences in 2004 in Kuala Lumpur, Malaysia, in 2012 in Wollongong, Australia, and Best Thomas Belfort Ground Improvement Journal paper in 2019. He is co-author with famous researchers like Croce and Mardoni of 2 books on jet grouting, the publisher is CRC Press, and he is co-author with Vigiani and Lancelota of the chapter on Foundations in Encyclopedia of Engineering Geology. The publisher is Springer. He is co-editor of different volumes on geotechnics and heritage. And recently he gave third Carisel lecture, there is an honorary ISSMGE lecture in 2022. And he's been invited and for many of the keynotes and SOA speaker to many international conferences. He's a collector of a number of competitive Italian and European funding grants. He is a coordinator of European Raw Material Committee (ROS). He is invited expert member of the European Innovation Partnership on Raw Materials, and his main research area includes ground improvement, liquefaction risk mitigation, geotechnical seismic isolation systems, mechanics of coarse soils, and preservation of historical sites. He has been involved in many preservation actions, restoration works of UNESCO historic sites in Italy and abroad, and he has been consultant for many large geotechnical projects of dams, tunnel, bridges, retaining structures, foundation, land reclamation, and ground improvement. So with this, a very short bio, I invite Professor Flora to deliver his keynote lecture today.
Thank you very much for your... Thank you, Jidesh, for your very kind introduction. Let me share my screen, just a second. Tell me if you can see my screen.
Yes, it is visible.
And now you see it in presentation mode. Let me check. Yes. Do you see it in presentation?
Yes, I can see that in presentation.
Yeah. Okay, thank you very much. So thanks again for inviting me. It's a pleasure. It would have been nicer to be there in person. I've been just once to India and I really enjoyed it. So I do hope to come and also to visit your fantastic monuments and historic sites. Now, the lecture I will deliver today is actually the Carisel lecture, which I delivered in a conference on the preservation of monuments we had in Naples in June, last June. And the title is Taking Care of Heritage, which is, in my opinion, a challenge for geotechnical engineers. Now, in this work, I have been discussing with a few people about the topic. So here you see listed the people I have to thank for their contribution, because discussing with people allowed me to better finalize my presentation and my thoughts on the topic of preservation of monuments and historic sites. Now, in this sketch, you see the shadows, actually, of the 3 Carisel lectures so far. I'm the third one, you see here, Mia, my shadow. And we are looking at the inspiring figure of Carisel. Jean Carisel, I think most of you know very well Jean Carisel. He was a very important and fine, smart geotechnical engineer and professor who at the end of his life dedicated his research in understanding the way the pyramids were built, and dedicated most of his efforts to explore the relevance of geotechnical engineering in the preservation of monuments. And in fact, when he was invited to deliver the ranking lecture in 1975, he delivered a lecture on the preservation of monuments. Now, these are the shadows of the 3 of us looking at the inspiring figure. But if you really want to know how I feel, how I felt actually when I was invited to deliver this lecture, I actually felt like a schoolboy. And so this sketch tells you better the way I felt. because, you know, the topic is fascinating, but very challenging. And so in this sense, I felt, in comparison with Jean Kérisel, like an old schoolboy, a schoolboy though. But the attitude of being a schoolboy, in my opinion, is always a good attitude when you have to study something, because you start looking at what other people have done. So what I did was to try understand what has been done so far. So that's why you see this writing. Where are we now in terms of the preservation of monuments and historic sites? And before going on, let me immediately remind you that the Technical Committee of the International Geotechnical Association on the Preservation of Historic Sites is named 301. And in the definition of these technical committees, the 100 committees deal with the fundamentals of geotechnical engineering. The 200 committees deal with applications, and 300 committees, and we are 301, that is the first one, deal with the interaction with the impact on society. So in our work on the application of geotechnical engineering to the preservation of monuments, it's not only a matter of speaking of new models or new technologies, but most important is to speak about the correct applications of our knowledge in geotechnical engineering to the preservation of monuments, which is a specific issue. So in this term, it has been done a lot of work, both in Europe and around the world, also in Asia. Professor Iwasaki has been very active in Japan and all Asia, and Italian and other colleagues in Europe as well. And now, in the last 20 years, in my opinion, the technical committee did a very good job, because it produced a number of publications which were a sort of reference, let's say, in the way you should approach the preservation of monuments. So if I have to say where we are now, the very first thing I can think of is what are the questions that have been fully answered so far by the people who have been working on this topic. In my opinion, the very first question fully answered is if geotechnical engineering is relevant for the preservation of monuments and historic sites. To you, this may look like a trivial question, but a few decades ago, it was not the case. And for instance, you see here the paradigmatic example of the Pisa Tower, because this was a very famous, worldwide famous example in which the problem was geotechnical and the smart solution they found to solve the problem was geotechnical. So the answer is yes, geotechnical engineering is very relevant. And another question which has been fully answered, in my opinion, is, do we have specific constraints? I mean, why should a monument or a historic site differ from other structures or sites? This is not a trivial question, in my opinion, but we now know that we have constraints. You see here in this chart, I will go back to this chart in the second part of my presentation, but I recall it here to remind you that we have, when we deal with the monuments, some constraints in terms of iconic integrity, material integrity, historical integrity, authenticity, which is an elusive concept, but is also very important. And you know, the amount of actions you can do are summarized here. So we know that there have been charts issued in the last century that deal with the constraints we have. So the question is answered because yes, we do have constraints, and these constraints apply, as you see down here, to the whole ground monument system. That means that they apply also to geotechnical problems. So we have to face these constraints. We cannot do anything we want on monuments. Now, if these are the questions fully answered, in my opinion, there are also open issues that say that it is still worth working on this topic. What are these open issues, in my opinion? Well, I list here the main ones in my opinion, of course. The first one is Is everybody aware of this, or I mean, of our role out of our community? Because we have the experience. You see here a sketch of a geotechnical engineering speaking with some experts from other disciplines. You know, we always try to say that our job is important, and sometimes people are kind to us. They say, yes, of course, but maybe this is not always true, and so they do not involve geotechnical engineers all the time they should be involved. So, I mean, the first problem is if everybody is aware of the relevance of geotechnical engineering in the research, in the preservation of monuments. A second question is if we all agree on the constraints. We have constraints when we have to approach the monuments, but do we agree on what are these constraints? This is something to be discussed, in my opinion. And the third question, open issue I have listed here is how big is the gap between theory and practice? Because in conferences, on papers, you usually see very nice applications of engineering, geotechnical engineering, to the preservation of monuments and historic sites. But is it always this the case? Or maybe there is a gap, and in practice they don't always do what in theory we say they should do. So in this lecture I will go through these three issues using some of my personal experiences in terms of preservation of monuments or historic sites to try and propose a possible answer, but which is not definitive, and of course these are topics to be discussed. Now let's start with the first issue. Is everybody aware of the relevance of geotechnical engineering? And let me start with an example in which I've been recently involved in Central America. It is a Maya site, actually an acropolis in a site named Copan in Honduras. You see here in orange reported the area where the Maya spread, the Maya culture spread during their best period, which is from the 5th to the 9th century AD, that's after Christ. And now Copan is on the highlands in the western Honduras, so it's on the border of this area, but it was one of the most important cities in the Maya civilization, where it was a very relevant cultural site where most of the mathematical and improvements of their culture were done. And also in astronomy, they had a lot of improvements in that area. Now, you see here some pictures from the site. This is the main compound, because Copan is very much famous for this compound, which is named the Acropolis, which is made of a series of connecting plazas and small and big structures you see here. I don't know if you see my mouse, so let me get a better mouse here. Okay. Now, this compound is very important. The pyramid in red is this one, the so-called hieroglyphic stairway temple, which is very important from an archaeological point of view. Now, the city flourished in the period between the 5th and the 9th century, but then was abandoned, and centuries ruined very much the place. You see here a picture from about 100 years ago, when the American archaeologists started to study in a systematic way the site. The river Copan, which runs close by to this area, had triggered a big landslide that you can see here, which ruined some of the pyramids. And so in a way, it was a shame, but the landslide also showed that inside the pyramids, there was something to be seen. And what was that? Actually, what the archaeologists have understood is that the Maya, when the city was growing in importance and in size, needed larger monuments. And so instead of building new monuments in different sites, they built the new monuments on top of the old ones. So let's say that monuments we see now are a sort of onion with inner layers of older Maya structures. You see here an example of what the archaeologists have found in one of the pyramids. So fantastic layering, very important monuments, really worth looking for. Now, how did the archaeologists go and look for that? They excavated narrow tunnels. These tunnels were about 1.5 meters large, 2.5 meters high, so very narrow. And of course, these pyramids, when the Maya built the larger pyramids, they buried the old structure, putting unsaturated fine-grained soil, which was compacted by hand with the technologies they had at the time. So it was an embankment in all cases. And so the tunnels were excavated through these embankments. Now you see here just an example of the crazy pattern, the crazy network of the tunnels under the Acropolis, because they didn't know what they were looking for. So they, for instance, went forward and they found a wall and they turned left or right, on down, on up. So it is a crazy network, both from a planimetric point of view and also from an altimetric point of view. So this, of course, posed a problem, because they started to have collapses in the tunnel. So they started to detect in a detailed way the shape and the position of the tunnels. You see here an example of scanning of a part of these tunnels with the crazy pattern I told you about. Now, originally all the tunnels were online, but as soon as they started to see some stability problems, they put on site different linings, as you see here, in a very, let's say, spontaneous way, so not systematically designed. And in the very first cases, like in this figure here, they also tried to mimic what you shouldn't do, the original Maya structure, which poses also some problems to the archaeologists nowadays. Now, all these tunnels are very important, because you see here, excavating still shows extremely fine pieces of art and stones, carved stones inside the big pyramids. So it is very important to keep this pattern of tunnels open, also for tourist visits, of course, because the site is becoming more and more important also from this point of view. Now, you see here in one of the parts of the Acropolis, the areas where they had problems recently in the 3 years between 2017 and 2020. In red, you see the areas where they had large collapses in the tunnels, and in blue, where they had very big water intrusion when they had rain. And you see here examples of some local collapses. Most times, and now we understand why, these collapses were triggered at the interface between the lined stretch of the tunnel and the unlined stretch behind. Now, you see here that the water was critical. In the 90s, they put an impermeable membrane in one of the plazas, but when the Hurricane Mitch struck the area, they got even worse collapses in the tunnels around the border of this, because there was no correct water discollection. The water was not collected correctly on the plaza and disposed. So they had higher infiltration on the border. Now, why I'm telling you all of this? Because clearly there is a problem with water. And the archaeologists from Harvard, which have been working for 50 years in this site, clearly knew it was a problem of water, but they, being archaeologists, had no clear understanding of why it was a problem. So they recently, in 2000, 2018 actually, called Professor Paulo Lourenço from Portugal, who is a famous expert in the preservation of monuments and historic sites. But he's a structural engineer. And when he saw the problem, he immediately understood it was mostly a geotechnical problem. So he was kind enough to involve me in this work. So we went to Harvard, we discussed with the archaeologists, and it was relatively simple to understand what the problem was. From a geotechnical point of view, actually, it is a trivial problem, because obviously it is a fine-grained material, unsaturated, so of course there is suction in the material, which is a function of the degree of saturation. So we could demonstrate by carrying out numerical analysis that this degree of saturation had an effect of stability by introducing an apparent cohesion, what we did in the numerical analysis, as a state parameter. What we used all the scanning of the tunnels to have, different shapes of the different tunnels with and without the Maya walls, and also taking care of the distance from the boundaries. And because of this, we were able to plot charts like this one. You see here a couple of papers in which we have published this with one of the students we have co-tutored, Paolo Lorenzo and myself. And you see that it was relatively easy to see that tunnel safety factor in terms of local collapse is a function of the degree of saturation. So we were able to tell to the archaeologists that there is a limiting degree of saturation that should not shouldn't be overcome to avoid collapse. So if this is true, and it seems logic, then it is very easy to think of solutions. Of course, we found that the decrease of suction may be critical, and therefore we need some actions in the medium and long term. Of course, there is always a problem of money when you're working on this kind of sites. So the first thing to do is the need of proper rainwater collection, new lining to be added in the tunnels where possible, but where it is not possible and the tunnels are dangerous because collapse can happen, we suggest to backfill, to close the critical stretches in the short term. Of course, excavating new tunnels elsewhere for safety reasons. You see here a picture we took in Harvard, at the clubhouse in Harvard. This is Paolo Lorenzo, this is myself. These are the leading archaeologists from Harvard, William and Barbara Fesch, and all the people also from the Instituto Hondureño de Antropología y Historia, from the Honduran institution taking care of the site. Now, I've shown you this example to show that in this case, good cooperation led to the solution, because from a geotechnical point of view, the solution was easy. It was necessary to work together. So this symbolic need of cooperation to solve the problems, because you need skills from different expertise. Now, let's go directly to the second issue I was mentioning you before. If we all agree on the existing constraints. Now, let's go back to the chart I showed you before. We have constraints, I told you, yes, because we have an iconic integrity, a material integrity, and a historical integrity, which is linked to authenticity also. And of course, you would like to be, with your engineering action on the monument you want to preserve, you would like to be on the top part of this chart. So you would like to touch it very little. You wouldn't like to reconstruct it, of course. So the lower you are in this chart, the less you are respecting the constraints. But sometimes you are forced, to carry on heavy actions. So there is a problem in intervening, because these constraints sometimes are difficult to respect. And what I can see is that by traveling around the world, I've seen that actually there are different traditions in different countries, different areas. And this kind of chart is not sufficient to say that all the constraints are listed here. So in my opinion, what is an additional problem in the solution, in the application of engineering to preservation of monuments is that there is the lack of unity of the solution, not only in terms of the mathematical solution, but in the broadest possible sense. That is, there are solutions around the world that are obtained in a different way. So what I like to quote this, which is an Indian parable. When I came to a conference in Chennai in 2019 on the preservation of monuments and historic sites, and I listened to a nice presentation by my friend and colleague Arun Menon from Chennai University, and he showed this old parable, which really is perfect for our discussion, which is the parable of the elephant and the 6 blind men. You know, these men had never met an elephant. They then meet an elephant. Each one is touching a different part, and so each one thinks of the elephant in different terms. So nobody's wrong, but nobody's right. So people from different areas of the world shouldn't think to be right on the basis, on the limited basis of his own experience, their own experience. And so I like the idea of the relativeness of any absolute truth when dealing with the preservation of monuments. So we need a shared and open-minded culture, in my opinion. And so how could we try and set forth and create, let's say, a framework on which we all agree? So what I did in the written text of my presentation, of my Carousel lecture, I said, why not complementing this list with a new kind of integrity? And I propose to call it functional integrity. I mean, in terms of built heritage, we have monuments that are still used for the purpose for which they were built. There are ones that are still used, but in a new way. There are ones that are just visible witness of the past. There are ones that are not visible by choice because you have, for instance, no money, and so the better preservation is to leave them underground. Or there are some which are not visible by ignorance. So the highest possible functional integrity is up here, and the lowest possible functional integrity is down here. So reading the papers of some archaeologists, I enjoyed finding that they say that what we should preserve is the so-called genius loci in Latin, which is the spirit of the place. So that's what we should be sure to preserve when we touch an historic site. So probably sometimes, and this is a question I ask, could continuity for a community in an environment of the role played by the structure to protest justify, of course, if needed, harder interventions? I mean, sometimes the material or iconic integrity constraints are too strict, and probably functional integrity should be taken into account. And I show you a couple of examples here. You all know probably St. Peter Church in Rome, which was built in the, let's say, obtained its actual shape in the 16th century, and as the center of the Catholic Church, and it is still used for that purpose. So at the highest possible functional integrity level. And I see, you see here also Notre Dame de Paris, the church in France, in Paris, that went on fire, had the roof going on fire a few years ago. And I put it here on purpose because after a harsh discussion in France, they finally decided to rebuild the roof as it was, exactly as it was, where it was. So somehow contradicting the charts, the 20th century charts, which put constraints. Why did they do that? In terms of my proposal, is because they think that functional integrity is very important. So they wanted to put the church back because it's still used as a church. An example of a visible witness of the past from my town is the very well-known site of Pompeii. And of course, this is, in terms of functional integrity, completely different from this. So if you have, of course, if you have a differential settlement of these pillars or of these pillars, probably if you believe to the role of functional integrity, you should accept to do different kind of interventions. So probably likely here you may have harder intervention, exactly like they did on Notre Dame de Paris. But of course, this is a tough discussion, and it usually is a discussion among archaeologists versus architects. And we are engineers, but still it is a problem that of interest to us, because we should decide if we going for harder interventions or not. And now I like to quote Salvatore Settis, who is a very famous expert of preservation of monuments and historic sites, who says, let me quote him, "Cities are not museums, they are meant to be lived in, and that's the reason why conservation supervision should not be perceived as a way of leaving everything in a state of hibernation. I don't wish heritage protection to mean hibernation." And I like, this is a guiding light to me, because this says that we have to be careful, we have to be careful in respecting the constraints, but we shouldn't think of the past as something to be in hibernation. And to better show you this, I will go through an example from my experience from Naples. This is an old map of my city, Naples. You see here the old part of the town, the Greek town, which was Neapolis, which means a new town, like New York in the old times. Now Naples is spread much more. Now, at the Roman times, this is a picture of about the first century before Christ, when these tunnels, of which I want to speak, were built. In that period, the Roman fleet was here because Rome is about 200 kilometers north of Naples. And here is Pozzuoli, which was a very important site for Romans. And the Gulf of Puteolis, which is Pozzuoli in Latin, had the battle fleet of the Romans. It was the largest harbor in the Mediterranean. So this was very important. Naples was a small minor city at that time. So if you wanted to go from the Roman town to the Greek town, you had to climb on the hill here and go down. It was a very long way. Because of this very famous architect, Lucius Cuceius Actu, decided to excavate a long tunnel. These are the 3 longest tunnels that Romans ever built, because the Neapolitan area is mostly made, as you can see, it's a volcanic area, as you clearly see, with all the craters. By excavating this tunnel, he made it much simpler to go from Pozzuoli to Naples, crossing the tunnel. So the tunnel, so I will speak now about this tunnel, which is named Cripta Neapolitana. Now, the Cripta Neapolitana is a long tunnel that nowadays connects 2 neighborhoods of the new town of the Naples, which are named Fuorigrotta and Piedigrotta. Let me remind you, because this is important, that Fuorigrotta in Italian means the exit of the tunnel, and Piedigrotta means entrance of the tunnel. And so the names of these neighborhoods are taken from the tunnel. Now, this is a cross-section of the tunnel, which mostly goes through an old volcanic tuff, which in the central part is extremely weak, sometimes going to be almost completely uncemented. So very poor material. Now, here is a reconstruction of the evolution of the section of the tunnel. The Romans were extremely good engineers, and they built a tunnel which was very narrow. This was the Roman tunnel, you see, in the 1st century before Christ. And it was a very stable tunnel. Why this? Because the Romans knew that the tuff on top was better. Then the different dominations came, and in the 5th century, in order to make, this tunnel is more than 700 meters long, so a small tunnel was not very nice with all the dust. So decided to have a better section to have more light, and they lowered the floor to this level, and it was still stable at that time. But then a big change in the section came a century after, during the Spanish domination, and Don Pedro de Toledo decided to make a big, much higher section in order to allow big carts, you know, and transportation, to make the transportation road much better. But when the floor was lowered so much, collapses started to be triggered. And in centuries, they tried all the possible countermeasures and retrofitting actions, but nothing was successful. And I go back here to show that there are masonry arches that were put also here later on, but they collapsed in time. So in the 20th century, they decided to fill part of the section, but still the section was mostly unstable. So in 1930, the tunnel was closed. And since then, it has been closed. If you ask to young Napolitan people, what is the Cripta Napolitana, they don't even know what it is, while it was the most important road in Naples for a long period. So it is really a shame. You see here the closed sections. You see this is me during one visit during the pandemic period. These are the two entrances now on the two sides of the tunnel, and these are pictures taken from one of our site visits in the tunnel. You can clearly see that the tunnel has mostly collapsed, and you see here some Roman masonry, some arches partially collapsed, but most of the tunnel has completely lost its shape. This is me daring to go in an area where collapse is still ongoing. You see here big blocks on the verge of failure. So indeed, a really critical situation. We did a lot of investigation. First of all, we did a laser scanning detailed to have a clear understanding of the shape of the tunnel now. And we did testing both in the lab and on site. I will not go into details of this, but we decided to carry out some numerical analysis. For instance, I will show the analysis in these six sections from A to F. You see here they have different different shapes, cross sections, because they mostly failed on time in the old times. And these are very briefly the outcomes of our numerical analysis, in which we found that the safety factor in the most critical section are basically 1. So confirming the extremely critical situation. Of course, I don't enter into detail, but the numerical analysis told us also where the most critical situations, and they confirmed that tensile failure of the side walls, the white dots are tensile failure dots, are extremely critical, so driving our possible solutions. So now, again, we should go back to the discussion on the constraints, which is why I'm showing this example. If we want to be very strict in respecting the constraints, we should keep the tunnel closed, because we cannot do anything with it. It's too dangerous, as you see here. But should we really do that? And in my opinion, we can bring this historic site back to the role it has, to the situation it had. It was a connecting path, a very important path. So why not bringing it back? And this is the proposal we are carrying out, and we are working on this with the municipality of Naples, because if we believe that functional integrity is a value, then even though we know we are losing some traces of its history, we can do works, also have interventions to put it back, this monument, this very relevant site, to the role it had in the past. So what should we do? Removal of small unstable blocks, bolting larger blocks, partial reshaping and insertion of a lining, of course, leaving windows to see the old shape and the old masonry, and of course, supporting the Bourbon arches like this one that are partially collapsed. So this is to say that we should be open-minded when looking to the different constraints we have. At least this is my proposal, of course. Now, let's go to the third and final issue I was mentioning in my introductory part, and which is how big is the gap between theory and practice. And let's say that in a way this can be considered an unpolite question, because this question needs, in order to answer it, we need to show something which has not been done in a perfect way. And I will do this by showing an example on which I'm currently working with my Turkish colleagues, and which are the so-called Theodosian walls of Constantinople in Turkey. Constantinople is the old name of Istanbul, so this is Istanbul. Now, it is a UNESCO site since 1985, and this date is important because after this date, they decided to do heavy intervention. And I will briefly introduce what these walls are, then to show you, to enter into some detail of the behavior of a tower, one of the towers, one of these towers, which is named Tower 19. Now, this defensive system built in the 4th century, in the 5th century after Christ, was an impressive defensive system. Look at here, there are two walls, an inner wall and an outer wall, with a system of towers, again, inner towers, outer towers, with a site on which the soldiers were at a higher level compared to the possible besiegers, and also a moat which made it very difficult for the attacking soldiers to get to the walls. Now, it was indeed an impressive system. It became legendary during the Middle Ages. It was constructed by the Byzantine during the, as I told you, during the 5th century. And of course, the walls and towers were immediately struck by heavy earthquakes, because it is a very seismic area, as you probably know. But then for many centuries, they had heavy attacks from different armies, but they never surrendered because they were basically invincible. They surrendered during the Byzantine period only once, but because the Crusaders, in a way, it was an unexpected sack of the city, and therefore the city was taken, but then was recaptured by the Byzantine, even though the decadence had started. Now, then the Ottomans came, and after an unsuccessful siege in 1422, in 1453, thanks to the cannons they had at that time, they succeeded in getting the walls and also the town, and they started the Ottoman Empire, which survived till 1922. Now the walls, you see here a sketch of probably the Ottomans were able to destroy with the cannons the very heavy and important, impressive defensive system, which without the fire weapons probably could have not been possible. Now, you see these pictures are from the German Archaeological Institution in 1939 and demonstrate that the walls were there, but with the decadence of the Ottoman Empire, they were heavy ruined, and they show, as you see here, clearly the signs of seismic damage, which kept going on time. It is important to say that the walls were defeated by people only a couple of times, as I told you, but they were destroyed quite a few times by earthquakes. And so there has been a continuous battle between man and nature. Nature was destroying most of the walls. People were, and the inhabitants were rebuilding them. You see here a map of the main earthquakes in the last 2,000 years, as reconstructed by Ambrasis. And you see here, our tower T19 is here. This is Istanbul. And in 1999, what happened? That there was a very strong earthquake, the so-called Kocaeli earthquake, which struck also Istanbul and damaging the towers. Now, let's go to tower T19, which is this one, as you see here. Because it became, since it became a UNESCO site, the authorities decided to heavily reconstruct the walls and the towers. So they reconstructed by mimicking, by simulating, reconstructing using the old technology. So as you see here, for instance, in our tower, there was an original Byzantine wall part of the structure. There was an original Ottoman part without the band stripes, the brick bands that the Byzantine used. And then the part that was reconstructed on the side was reconstructed using Byzantine technique. So from the point of view of constraints, there was no respect. And actually, not only in terms of integrity, authenticity, and so on, but also from the functional point of view, because, you know, this tower is not defending anymore the town. So there is no functional integrity to set back. So anyway, they had rebuilt as new the tower and others as well. But then the earthquake came in 1999 and destroyed most of them. As you see here, you see the different sides of this tower T19. Parts were collapsed, large cracks. You see here typical seismic cracks. This block is on the verge of collapsing. So a big damage of the wall as well. And now I'd like to quote this sentence from Professor Hound Bai, who is the chair of historic preservation at Istanbul Technical University. And this is what he said after the 1999 earthquake. And I quote it, I read it. The restoration campaign of the 1980s must be criticized due to its resort to the reconstruction of ruined towers and gates instead of stabilizing and consolidating dangerous structures. The performance of the 20th century repairs, the ones I told you, during the recent 1999 earthquake constitutes a good lesson for future restoration. So Professor Hanbai is saying, why did you concentrate on the shape? Now we have the knowledge to do better. Why should we keep going on and on in this endless game between man and nature in the destruction of this structure? So we decided to get some better understanding of the behavior of this tower during the 1999 earthquake. Now we had a very detailed knowledge of the geometrical features of the tower as it was reconstructed, of the subsoil with the layering and with the properties. Here you see the shear wave velocity profile with depth, and also we had information on the shear modulus degradation curves and the damping curves. So we were able to carry out simplified and complete analysis, both linear and nonlinear. You see here the Plaxis 3D simulation we carried out of the tower with the walls. Now, I am just briefly recalling this to show you what. That if this is the tower and this is the response spectrum, of course we were lucky in this case because we had a registration at the station, the so-called Fatih station, 4 kilometers away from the site during the 1999 earthquake. So we were able to deconvolve the signal to the bedrock and then to propagate it to the tower. So taking into account a local site, seismic site response. And you see here is the response spectrum at the foundation level in the north-south direction. The tower is not symmetric. The north-south direction is orthogonal to this plane. And the natural period, well, first of all, let me say that the spectrum has this high peak because there was a resonance between the natural frequency of the site and the dominant frequency of the striking earthquake. So very big possible actions. Now, if you see at the natural period of the structure, considering with a fixed base, so without taking into account the subsoil, this would have been the seismic demand of the structure. But if you consider the compliance of the base, so you do take into your analysis the behavior of the old structure, you see that, of course, there is an elongation of the natural period because there is less constraint at the base. You know, even though the limestone is pretty stiff, the rotational and normal stiffnesses are lower than the fixed boundaries, of course. And even though the lengthening, the elongation is not so large, since we are on the rising branch, rising part of the spectrum, response spectrum, there is an enormous increase in the seismic demand due to seismic site, the seismic dynamic soil foundation structure interaction. So in this case, we have the tools to understand that the compliance of the base plays a detrimental role. So this should be taken into account in the analysis. Why reconstructing the towers without carrying out this analysis? Of course, this is a deterministic back analysis of what has happened. If you had to design new actions, you should carry out a probabilistic analysis, but still you can do that. We have the tools to do that. And it is interesting also to see that the seismic component in the orthogonal direction is much less critical because the elongation of the period does not induce any relevant difference in the seismic demand. So the critical situation is on the north-south direction of the action. And you see here the results of the nonlinear analysis, which the hot colors means that the high tension stresses have been reached and possibly failure. You see, so a cantilever kind of failure of the structure is built. So we obtained under the seismic action, considering the full interaction between the nonlinear interaction between the structure, considered nonlinear, and the soil, considered nonlinear, and we got consistent results because the structure failed. So we also considered what would have happened if we would have had some mitigation measures. For instance, I am working now on a very soft action, which is lateral disconnection at the foundation level. If you disconnect a foundation, you highly decrease the rotational stiffness, so increase the compliance, and so you increase the elongation of the natural period, let's say in terms of equivalent elastic behavior. But you see here from the nonlinear analysis that since the foundation is too shallow, so the depth is not sufficient to modify the behavior, still there are very critical sections in which the masonry fails under the seismic action. So we also consider different options like soft barriers. We are working on a geotechnical seismic isolation technique, which is a soft grouting in which you inject a grout which has a low normal stiffness on the sides and a low shear stiffness on the base, and the situation gets better. You see the colors become cooler, tending to blue, but still this is not sufficient, and to be honest, it is always also a very complex way to intervene on a site. The best option would be moving on in the other direction. Instead of lowering the stiffness at the base, at the foundation level, you can grout around and the base, stiffening the soil, so moving towards the origin of the response spectrum. And if you also do some retrofitting, so some intervention on the masonry, you can have a much better result. So the reason why I showed you this example is that we have the knowledge to do better, even on extremely important heritage sites like this. Sometimes intervention forgets that we have the skill to do better. And so now the structure should be rebuilt if they want to have it as it was. And the claim I have here is that we should insist and say that geotechnical engineers and structural engineers together can solve the problem if they are involved at the right stage of life of the intervention. Now, let me go through to the conclusions, which are actually not conclusions. In my opinion, they are final remarks. And let me start with these two pictures I like because they remind me of two risks, and I call them risk 1 and risk 2. Risk 1 is the lack of cooperation, and risk 2 is cultural isolation. And in my opinion, they are the two sides of the same medal, which is ignorance. Now, on the role of geotechnical engineering in terms of the risk of lack of cooperation, it is obviously essential to share the responsibility of technical solutions with experts from other disciplines. We have said that. But of course, because this cannot be but based on multidisciplinary considerations, but of course, this multidisciplinarity must include geotechnical engineering. We have tried to demonstrate that most times geotechnical engineering is important to understand the critical situations and to propose respectful interventions. So this is in terms of lack of cooperation. In terms of cultural isolation, I'm speaking to people most from Asia, and I'm from Europe. I am fully aware that in the past preservation actions, let's say the framework has been mostly European, Europe-centered, let's say, which is not what should be, in my opinion. First of all, let me say that hibernation of heritage is not the only solution. So we shouldn't freeze the cities as they are. We should not be afraid to intervene on the structures because it can be worth to increase the functional integrity, possibly to bring it back to where it was. And the second is that must be recognized that cultural differences exist around the world, and this should be a matter of discussion on the best way to intervene and on the exact kind of constraints we should use. And so to really conclude on the gap between theory and practice, let me remind you that maybe you know Kant, the German philosophy, did the categoric imperatives. Now, there was a philosopher in the 80s, in 1984 in particular, who introduced the so-called imperative of responsibility, which I really enjoy, and I rephrased it. So let me read the way I modified it. When we intervene on our structures, on our historic sites, we should act in such a way that the consequences of our actions are compatible with the permanence of an authentic life of the historic structure or site on which we operate. So if we really want to conclude, what we should do in our committee, in our community, around the world, is to fight against ignorance. And with this, I am over with my presentation. Thank you.
Thank you very much, Professor Flora, for delivering this lecture. Now we keep this particular session open for discussion. So participants, if you have any questions, please feel free to ask directly. Yeah. Yes, please, Dr. Naresh.
Should they stop sharing the screen, or should I can keep it in case of questions?
Yeah, you please keep it. Yes.
somebody has raised the hand.
Yeah, you can unmute yourself, Dr. Naresh, and then you can ask the question. Yeah, you can please ask the question. You need to unmute yourself. Dr. Naresh, you please unmute yourself.
I see also Yoshi Vasaki asking. Dr. Naresh, you should unmute your microphone. Your
Flora.
microphone is off.
Flora.
The Professor Iwasaki. Hello, Yoshi. How are you?
First of all, I have to thanks for your treatment when I was lost
No
in
problem.
Napoli.
No problem. No problem. It was a pleasure.
Today's your presentation was very interesting. Yes.
Mhm.
The second presentation is tunneling. The tunnel is one of the best item for Italian engineers. They are just putting their new weights, except the NATOM. NATOM was developed outside of Italy, but the Italian had another technique. By the way, at this time moment, you just showed the shear stress, shear failure, and the tension failure zones. However, is there any field monitoring at this time moment?
You're asking, yes, of course.
What kind of the field monitoring?
For time constraints, I couldn't present all the data, but what I was trying to say is that the simulations were carried out demonstrated that it is possible to, I mean, by looking at the failure mechanisms, we saw mostly detachment of the lateral blocks. We saw that the numerical analysis allowed to confirm that this is a critical mechanism. And so now we are in the phase that if the archaeologists agree on the heavy interventions to recreate, to increase the functional integrity, then we will do some bolting or dismantling of the small blocks to allow. We want to have a cycling path and a walking pedestrian path there.
I see. I have many questions, but probably
we can discuss later. We can discuss on a private chat.
Okay, thanks. At
Thank
this
you.
moment, I will stop my question.
Thank you,
Dr. Naresh, you should unmute your microphone.
Okay.
Or maybe you can pose the question also. You can type in the chat box and you can pose the question. Do we have questions from other participants?
Hello, sir. Good evening, sir. I hope I'm audible.
Hello.
Yeah, sir, if I want to know more about the monumental structure geotechnical history, to know more about it, can you suggest me anything where we can find any documentaries or anything like that? Thank you, sir.
I can send to Dr. Chavda the written text of my Kerise lecture, in which there are some details and there are references, if this is fine. Jitesh, I can send you the article. I don't know if you already have it.
I have it. I'll forward it to all the participants.
You sent it. So this is a simple possible way. Then there are other publications but they are mostly quoted in that paper. And then, of course, the archaeologists wrote a lot, you know, on the Honduran side. There is a huge history, so there is a lot of material around.
Yes, sir. Thank you so much.
So
Sir.
you please write me if you have any specific question. No problem. Please contact me and ask a specific question, and I may try to answer you. Okay.
Sure, sir. Thank you so much, sir. Sir, even we have IGS student chapter. Even I will plan you to contact you, sir, regarding it. Thank you so much.
Perfect. Dr. Naresh has finally unmuted. Hello.
Yeah. Actually, I was involved in restoring some of the 3 historical sites in the then Andhra Pradesh. So we don't have any structural or foundation drawings. I being in the geotechnical,
I didn't understand. What site?
there are 3 structures, ancient structures of 3rd and 4th century. One is the Ramappa temple, another is the 1000 pillar temple, and Warangal fort.
Okay.
So it is located incidentally in black cotton soil. And the foundation, we didn't have any details, but due to earthquake in 1930s or so, the cross beams all got damaged. There were no shear beams, they were all damaged. Then we went for first studying what is the problem. So we didn't have foundation drawing. So we have gone for seismic refraction test all around the existing building. Okay. After about 3 meters deep below, they had laid 2 meters of sand to take care perhaps of the black cotton soil then in 3rd and 5th century. Between that time, this was constructed. That has been taken care. Only thing, the shear walls, the beams, could not take the load of the earthquakes. So anyway, we have gone for lime slurry injection all around the foundation, and we have restructured the beam, or rather jacketing it with steel sheets matching to whatever earthquake that was there. Because you have mentioned in your last 2 or 3 slides before, geotechnical engineering looks at multidisciplinary considerations. So in this consideration, in your tunnel, which you have mentioned, first was which was done by Rome, and later on again in 15th century, and later on you have, today we have what is called as tunnel boring machine.
Mm-hmm.
This, which is actually the machine that is developed by Germans, and it is being used in our metros, especially the ones which are
also here, everywhere, also in Naples.
Yeah. So why this was not used?
Well, because
in your in the tunnel that you have mentioned, where there is a huge
because I mean, there is no need. I mean, tunnel machines, first of all, are extremely expensive tools, and they are usually used, at least in Italy, for long tunnels. It's worth using tunnel boring machines for large tunnels, long tunnels. This is not so long. Then the tunnel exists, so there is no need for such a heavy intervention. I mean, it is absolutely possible to. There is not much to excavate. There is much more to sustain on the sides or to remove the blocks. Because if you put in place a tunnel boring machine with precast facing, you would have a modern tunnel, which is not the case. I mean, we want to have functional integrity. That is, we want to allow people to go through, use the tunnel again. But still, we would like that when they walk into the tunnel, they see that they are in a very historic tunnel, not in a subway tunnel. That's a difference.
This is the purpose to avoid failure or collapse or whatever damage to be done to the tunnel. So to avoid that recurrence, I have only mentioned tibia. to avoid recurrence, because it has happened twice at your place.
Okay.
So
Yeah.
that is the reason. I know you have some structural things. It is not that you get only in bigger diameters. You can shape the tunnel machine or diameter, whatever shape you want. So that is possible.
Going back to the monument you mentioned, as Jidesh knows, I would like to come to India and visit some of your monuments, because I've
Actually, you will get
I've
good.
seen only a few close to Chennai when I was there, and I think the idea of intervening on the soil, on the subsoil, so using what I call geotechnical seismic isolation systems, is intriguing, is very interesting, because we don't touch the structure, or at least we touch less.
Today you have seismic refraction test, in that there are many developments that have taken place, and many, like what we have in Delhi Metro and other places, there are a lot of old cables. How to avoid that? So we went for this rapid geotechnical system, and one of them was the seismic refraction test. And today you have advanced in seismic refraction test and found out what is the obstacles that are there, and then you went for the tunnel. So this also is possible in antique structures. Today, what I mentioned about the Ramappa temple has been 2 months back, it has been dedicated to World Heritage, built into the third to fifth century.
Okay, very, very nice. Okay, thank you.
Yeah. Only thing, that time, I agree, there is some amount of awareness of earthquake, but not this much magnitude, which has come in 1900. Anyway, it's a good presentation, sir.
Thank you.
Thank you.
Yeah. Do we have any questions from the other participants?
Yeah, I think it's.
Yeah. I've already posted Professor Alessandro Flora's email ID in the chat box. So if you want to reach him, you can please email him.
Absolutely, yes.
Yeah. So if there are no questions here, so we can end the session here. So let me,
Okay.
Professor.
Okay, Flora. The rest of the time.
Yeah, thank you. I think I have already told thanks.
The next one is the Tower 19. Tower 19.
Tower 19, what?
Seismic response. Please show me the ground layers for the response analysis.
Yes. You mean now?
Now, yeah.
Now, let me.
It seems like
do you see my screen?
Yes. Oh, yes. Yeah.
Let me show you here.
Oh, yeah. The base of the structure, tower, is just on the very hard
limestone.
The airway velocity is nearly 400 meters per second.
Correct.
So they are nearly very stiff. Stiff soil or soft rock type. So
yes, and it's a soft rock. And what I wanted to say is that even though it is a very stiff material, so the soil structure interaction, you see here, the elongation of the period from fixed boundary to fully compliant is not so significant. Since we are on the rising branch of the response spectrum, there is a huge increase in the seismic demand. The pseudo acceleration is much higher, twice as much. So even though the soil is very stiff, it's a soft rock, as you said here, And this is also the reason why, in this case, the lateral disconnection was not effective, because by removing the soil on the sides, you don't solve the whole problem.
Right.
Because
right.
it is very stiff. But you know, some of the towers, I didn't have time to go through this, but some of the towers, because there are more than 90 towers, are not founded on such a stiff material. And in that case, lateral disconnection can be very effective.
Yeah, understandable. So the
Okay.
those difference of the spectral acceleration is mainly due to the not from the soils, but the upper structures, structure characteristics.
Well, no, the difference from this to this is the elongation of the period depends on the lower stiffness of the system, because it is more compliant. It is a stiff material, but still not as stiff as an infinite stiff material.
Oh, really?
Okay.
Maybe I need some time to understand. Okay,
Yeah.
thanks very much.
Goodbye.
Yeah, so we can end the session here. And let me summarize Professor Flora's lecture. He has talked about the carousel lecture and the relevance of geotechnical engineering, especially for the preservation of heritage sites. And then he discussed with us in very much in detail about the three issues which are related to historic preservation. And more he focused on the functional integrity. He discussed the three case studies. That is, first one is on Acropolis of Copan, that's in USA. The second one is in Crypta Neapolitana,
It's in
Italy.
Honduras, not USA.
Yeah, I'm sorry if I it's in Mexico.
Honduras.
Okay. And then the second one is Crypta Neapolitana, it's in Italy. And the third one is Theodosian Walls of Constantinople. It's in
Very
Istanbul,
difficult.
Turkey. So really, and we had a very interesting discussions. And thank you the participants for attending the talk, and Professor Yoshinori Iwasaki from Geo Research Institute of Japan to attend this lecture and to interact with all. So with
Thank you very much for the invitation. It was a pleasure to see you.
Sir, sorry for being late. Can I have a question?
Yeah, Vidya, please.
Hi, I'm Dr. Vidya. I'm from Sarathi Geotech, Bangalore.
Hello.
It was a very nice presentation. Thank you, sir. Can I know what influenced you in this topic? What are your basic research material you read to develop this interest? Can we have a privilege of reading them too? Can you share it to Dr. Jitesh so that we can get it from him?
I am sorry, I'm not sure I understood your question.
What I mean is, you might have read a lot of articles of the like the history of the civil engineering constructions and failures. Can you share us those articles via Dr. Jitesh?
Okay, one of the things I will, but just to let Dr. Chavda didn't tell you, but he's the secretary of the Technical Committee 301. One of the things we should do on the website of the Technical Committee is to add literature references for people like Vidya, because she wants to read something. She said she's asking, where can I get the information I need on this topic? So there is a huge amount of literature. We should try and list. So it is a stimulating action that Dr. Chavda and myself should do on the website. But I will try. If you look at my Carousel lecture, the written text, there are a lot of references there. Some of them may be interesting. But again, if you have a specific question, don't hesitate to contact me. Write me, and it will be a pleasure to answer. Okay?
Sure, sir. Thank you. Because India, we have young mountains here, and we have, a lot of tunneling and new infrastructure projects coming up. So it will be
They may interact with the old structures, which is critical. A lot of work to do for good young geotechnical engineers.
Thank you. Thank you.
Okay.
Thank you, Dr. Vidya, for.
Thank you.
I'll do that, Nipul. I'll forward some of the literature. I'll forward Flora's lecture also, so you can go through the references from there also. And really, it is very much needed if we can do this. If we can put all the literature in the website EC301, it will be helpful
We should do
to
this. Let's
everyone.
try and think. Maybe Yoshi can help also. He has a lot of literature for sure.
Sure.
Okay.
Thank you. Thank you.
Thank you.
Okay, so I thank one and all, and I thank Professor Flora for accepting the invitation and delivering this lecture on behalf of IGC. I thank you very much for sparing the time with us. Thank you. And thank you all the participants also.
Okay, goodbye. Bye to everybody.
Okay.
Okay, bye now.
Ciao.